Hello, my name is Austin Johanningsmeyer. Welcome to my presentation on bridge design pattern. Intent. The intent of the design pattern is to decouple an abstraction from its implementation and to have an accessible interface while hiding the implementation in the inheritance hierarchy. Motivation. You would use this in a scenario where inheritance hierarchy is potentially explosive. That's something we want to avoid. So to do this, we would refactor the system to use the bridge design pattern. Doing this, we will separate the system into two hierarchies, one for the independent abstractions and one for the dependent implementations. This would allow us to scale our dependent implementations separately from our abstractions. So for my example of this pattern, this will be the gourd carver program. So we can carve multiple types of gourds and carve different types of patterns into them. We will use watermelons, butternut squash, and pumpkins. And we will carve happy faces, angry faces, or a cat face. So here you can see the class diagram describing the structure of the gourd carving program. This is the abstract gourd class. It defines that all gourds will have the function carve and that they will all have a iCarving implementer instance. And this is the iCarving implementer. It's an interface that defines the type of faces that can be carved into our gourds. And it has the function display that will display what type of face has been carved into the gourd. So this is our pumpkin class. It extends the abstract gourd class. So here you can see that it is passed in a iCarving implementer, and it sets that to its global variable. And it has the function carve, which will display that this is a pumpkin, and then whatever type of face was passed into it. Here's the butternut squash class. Just like the pumpkin class, it extends the abstract gourd, takes a instance of iCarving implementer, and it displays what type it is, as well as what face was being carved on it. This is the happy face class. It extends our iCarving implementer interface, and it has the display function. The display function simply outputs happy face, as it will be used by the gourd to say what has been carved into it. Here's our angry face class, just another example. Also extends the iCarving implementer interface and has a display function, while this one displays angry face instead of happy face. And this is our program. So here you can see that we are only using instances of abstract gourd and turning them into different kinds of gourds. And as we do that, we're also telling the gourds what type of face we're going to have carved on them. And down below, we actually call the carve function for each of our gourds, and this will display what type of gourd and what's been carved into it. And here is our output. We can see that the statements printed that the types of gourd, pumpkin, or watermelon, with the different types of faces that we attach to those gourds. So disadvantages of this pattern. You may increase code complexity by applying the pattern to a highly cohesive class. So you may end up with unnecessary complexity. Advantages, it decouples your abstraction from your implementation, so you can change both separately. Your client code will work with the high-level abstractions, making it much simpler for the client. Known uses for this would be splitting up and organizing a monolithic class. So basically, one big class might be able to benefit from some organization through this pattern. It's also used when you want to switch implementations at runtime, so it's very easy to change which implementation you're using. And when you want to expand a class in different dimensions. So it's very easy to expand, say, just the implementation and not touch the abstraction whatsoever. Thank you.